Cha-ching! How's it going, my compatriots, my friends, my students? Not yes, does not, yeah. What? Yeah, es ist gut, yeah. Cool, we've got, wow! 10 people. 10 people. It's gonna kind of feels almost like the face-to-face lessons next week. I have nothing left to motivate me. That's sad. That's a sad turn of events. I'll tell you, well, hopefully this cyborg Tyrannosaurus Rex is motivating all of you right now. Because there he is. Well, okay, cool. We got 12 people here. To be fair, it is 2 p.m. on Tuesday, but still, no excuse. I mean, I'm doing it at this time. This is the time that you guys wanted. You know, I gave you the option, and this was the time that you guys wanted. So, you know, all those people that voted for this time and are not turning up, you know, they got no excuse, have they really? I have just sent out something on Show My Homework. I originally put the wrong link. Hopefully they can now find the right link. But anyway. Okay, and Evie's got it open in 2 locations. I don't know whether that counts as 2 concurrent viewers if you're watching it from the same account, whether it counts the accounts as separate or whether it counts the views as separate. Okay, fine. Why wouldn't you just have a full robot T-Rex? Well, I mean, that's a question for the ages, isn't it? So anyway, let's crack on with this before I waste any more time. I mean, that was me trying to kill some time while people arrive, but it doesn't look like anyone else is coming, so let's just crack on. If you don't have your notes open, you should probably have your notes open. This topic, it's not quite, it doesn't quite fall under the translators and facilities of programming languages topic. It's kind of on its own, but it does it sort of is related to that topic. All right, because the facilities and the translators and facilities of programming languages topic taught you a little bit of things about how to find errors in your programs. We looked at things like the debugger, and we looked at what was actually going on in your IDE in terms of error reporting and stuff like that. Well, this is sort of this is how to design programs to minimize the amount of errors that we get in the first place. That's kind of what this is. So it's sort of a new topic. I'm not entirely sure what section this falls under in the spec. If you just give me 2 seconds, I'll be able to find out for you. I'll be able to give you the exact title as it applies to the OCR GCSE spec, and it is GCSE Computer Science specification. It falls under okay, it's its own section in the spec. This is a paper 2 section. It falls under the purview of computational thinking, algorithms and programming. The sections in that area are algorithms, obviously, programming techniques, which we've had some substantial looks at producing robust programs, computational logic, translators and facilities of languages, and data representation. So it's all in the same sort of section, but producing robust programs is a section on its own. So if you wanted to put a section in your notes called producing robust programs or designing robust programs, that would be cool. Welcome, Nicola. If you think about it, life and death happen in you all at the same time. That's not really related to designing robust programs, but we'll come back to that. So, first of all, your tier 2 vocabulary question here. What does the word robust mean? Does anyone know off the top of their head, or can you do a quick Google search on dictionary.com or something similar to that? What does the word robust mean? And based on that meaning, what do you reckon that means in terms of computer programs? I'm going to carry on drinking from this wonderful mug given to me by wonderful students. Strong, yes, strong or durable, able to withstand a good old beating. You are no longer a salad. Yep. Don't know what that means. So if smack and no break, then robust. Yeah, there's a way of putting it. So what does that mean in terms of our programs? So obviously that's the reason why I put the cyborg T-Rex on there. I mean, a T-Rex, fairly durable animal, but coat it in stainless steel and give it some weapons, even more robust, right? It is a very cool mug. Only the coolest student would give me such a mug, right? A program that has good coding in. Yes. Can we be more specific though? What is that program not likely to do on a regular basis? George with unnecessary non sequitur there, and it can cope with errors during execution. Yes, if something happens which is unexpected or would normally cause the program to die, rather than dying, it handles those errors. Okay, it's robust, it's sturdy, it is not going to crash. Okay, now there's lots of things that could cause a program to crash once it's running. Memory errors, other programs that are opening and data getting corrupted. And a robust program will be able to anticipate those sorts of things and carry on working. Ubisoft tend not to make robust programs. I need to get that. Next time I make a funny quip, I will get that air horn sound effect. Where is it? There we go. That's queued up, ready to go next time I drop a hilarious line. So we are going to have a look at how you can design programs so that they don't just fall over when bad things happen. Okay, because you're at the point with your programming now where, okay, you might not understand absolutely everything that's going on, but you can write a program that takes input, processes that input, and generates an output. What you probably haven't really thought about much is how can I make sure that that input that I'm taking is not going to destroy my program? Okay, for small projects, you might think, well, if that's not really necessary, I don't have to worry about that, but potentially you might. I mean, there's plenty of programs where even if it's just something as simple as asking a user to enter their age, you can make them crash. So we'll have a look at that. And just to address a falsehood that George pasted in the chat there, C is not as good as C++. It depends what you're using it for. C is far better than C++ if you're developing monolithic operating system kernels. So something like an interpreter isn't very... Right, okay, so let's get this straight here. It's not the interpreter which is failing on a single error, right? Because if that was the case, then when you ran your program that had an error in it, PyCharm would shut down. Okay, remember, the interpreter finds those errors, it stops your program running, and it gives you an error message so that you can find your... The interpreter is still running. Okay, it's not the interpreter that has died. It is your program that has died, and the interpreter is there spitting out that error for you. Does that make sense? So interpreters have to be very robust. If they fall apart when your program has an error in it, then obviously that's a bad thing, right? And so we're going to have a look at how you can make your programs more robust, so that the interpreter can run them without them falling apart. Okay, are we good? We've got a general idea of what it is that we're going to have a look at today, yeah? Cool. Right, so objectives for this lesson. I can't actually remember if I taught you the 3 different types of software error. I have a feeling that I did, but I mean the fact that I can't remember whether or not I taught it suggests that maybe you guys might not be able to remember them regardless. But can any of you tell me what the 3 main types of software error are? Or at least tell me whether or not I taught you what the 3 main types of software error are. It's not memory, user, and program. That is a pretty good guess. But no. User error. User error, I mean, we're talking about errors in your program, not necessarily errors in the end user. I did, but it was a while back. Okay, cool. So, any idea? What if I gave you a clue? An overflow error is a specific error which falls under the broad category of one of these 3. Okay, if I told you that the first one begins with S, that's me drawing an S. SY. See how long it takes people to clock this. There we go. Syntax error. Syntax error. Can someone tell me what a syntax error is? And Alex is correct with runtime error. An overflow error is an example of a runtime error. So we've got syntax error, we've got runtime error. Yeah, the computer doesn't understand. So a syntax error is an error in which the computer does not understand what you have typed in. It might be that you've given a garbage command. It might be that you have spelt something wrong, or you've put a capital letter where there shouldn't be. It might be that you've tried to use a variable that doesn't exist. Regardless, it's a literal error that causes the computer to say, nope, don't know what you mean, and they will cause your programs to crash. Okay, a logic error, as Alex correctly points out, logic errors don't cause your programs to crash, but they cause them to produce unexpected output. Anytime you have a bug in a video game where you end up clipping through a wall or something like that, that is a logic error. It means that data is being fed and processed in a way that was not anticipated by the programmer. Or maybe it was anticipated by the programmer, but it occurs so infrequently that there wasn't. It would have been more difficult to fix that particular error than it would have been to just leave it in there and hope no one found it. And then, don't worry, we're getting to the animal. You've already had one animal pick. We had a picture of a cyborg T-Rex. That's an animal. Don't worry, we're getting to the animals. In fact, I should have had this on screen while you were thinking of the main types of software error. Obviously, this is not a software error. This is a toucan, as it says here. Toucan, one of the finest birds that exist or have ever existed. Look at that majestic pose. Look at his beautiful beak. Definitely not a software error or an error of any kind. You cannot possibly call a toucan a mistake. Okay, so Syntax error is where the computer doesn't understand what you've typed in. A logic error, sometimes also known as a semantic error, is where the computer understands what you've written, but maybe that wasn't really what you wanted the computer to do. Okay? We'll have a look at some examples of those. And then the third one is a runtime error, where all of your code is fine, everything's working fine, but something that the user ends up doing causes an error to occur, or something that happens during the processing of your program, because of the way that it's structured, causes an error to occur, which might end up crashing the program. It might end up causing unexpected output from the program. Okay, so let's just have a quick look at these in depth. If you don't have these in your notes, now is the time to add them to your notes. So we've got syntax error, when the computer does not understand the statement. Semantic error or logic error, when the computer understands the statement but does not do what the programmer expects. In fact, that can happen quite a lot if you're unaware of things like bidmass. Is it bidmass that you guys use? The order of operations in maths. If you don't have your brackets in the right place, and you are doing some complex arithmetic, you may get inaccurate results. It can also arise from using floating point numbers, where integers would be more accurate. Floating point numbers are inherently inaccurate due to the way that they're stored, which you will learn about at A level, but you don't need to worry about at GCSE. But the using unsuitable data types can lead to logic errors. And then runtime errors are caused by errors during data processing. The classic example is a divide by zero error. To give you an idea of what I mean by that, if I pull up PyCharm here, let's ignore that for now. We'll come back to that. In fact, I'll create a new. Let's call this runtime. This is just a quick example to show you what I mean. Let's create a function called divide. Yeah. So divide, and we're going to take two numbers, A and B, and we're just going to return A divided by B. Now, I know this is obviously a stupid this is a stupid function. It doesn't really make much sense, because you could just like do this. I'm doing this as an example of how these sorts of runtime errors occur. And let's have some input. We can say A equals, so let's put UA equals, these are crap variable names, by the way, don't use these variable names. Int input first number, that's not how you spell number, and then we can have UB, see where I'm going with this, equals int input second number, and then we can say print divide UA comma UB. Now if I run this program, what it's going to do is it is going to ask me to enter a number, it's going to ask me to enter a second number, it's going to divide those numbers, and then it's going to print them out. Okay? So here's my first number, I put in 10, a second number I put in 2, boom, it calculates that 10 divided by 2 is 5, okay? Our code works, it's fine, there's no syntax errors in there. If there was syntax errors in there, we wouldn't be able to run through it. There's also no logic errors in there either, because it doesn't matter how many different numbers we type in. Let's say first number, I don't know, 156. Does anyone know what 156 divided by 3 is? I'll give you a couple of seconds to write a response in the chat before I hit enter. 156 divided by 3. In 5, 4, 3, 2, 1. It's 52, 52.0. Okay, so we know our code is free from syntax errors. It's also free from logic errors. However, what if I do this? First number, 278, let's say, right? Second number, 0. What's going to happen when I do this? What's 278 divided by 0? The universe explodes. Well, let's find out. The universe will not explode. However, if we describe the universe as this program and we define exploding as crashing, that's what happens, right? We get a traceback error. You cannot divide by 0, regardless of what you do, right? Max, just to answer that query that you made there, I didn't make it a float and it's displaying 0.0. Anytime you use the division operator, it will always convert to a float. Okay, even if the result is a whole number, division will always convert it to a float. So that's where the 0.0 is coming from there. All right. So yeah, we can't divide by 0, so the program crashes. We get this traceback, and it even tells us, look, it's a 0 division error, division by 0. The error occurred on line 2. It was called in line 8. I mean, this is a small program. We know what the problem is. There's not a problem with our code. The error occurred at runtime. The error occurred when the program was run. Okay, it's down to the user entering that stuff. So, how do we deal with that? So, out of interest, can anyone suggest another runtime error that I could make, that I could use to crash this program, this specific program, that doesn't involve dividing by 0? There's another way that we can force this program to crash based on what's going on here, without divided by 0. Can anyone suggest to me? So let's run the program again. Yeah. Yes, you guys are entirely correct. So James says letters. Alex says first number equals hello. If I do that, oh look, we get an error again. Again, nothing wrong with our code here. Okay, it becomes an error when the data that's input is then fed into this, and that's something that happens at runtime. Okay, does that make sense to everyone? The difference between a standard syntax error where the problem is with your code and a runtime error where all your code technically is correct, but it's something that the user has entered, which is causing it to run to fail when it's run. Does that make sense? Excellent. You may also find sometimes that these errors occur when, let's say you've got a loop in there and it runs through the loop fine the first like 10 times, but then the 11th time something has changed, which causes the issue to occur again. That's, in a way, that's a kind of a runtime error, because your syntax maybe not entirely correct, if it's if you're looping through something which doesn't exist, but that's something that can give you a what nonsense are you posting here, Alex? Right. So let's just go back to our presentation here. Nope, that's not how you do it, Carl. Where's the thing? PyCharm, get rid of that. Boom. Okay, so we've got our 3 types of error. We've got the syntax error, we've got the semantic errors, and we've got runtime errors. Now, fixing syntax errors, pretty easy. You find out where the code is wrong and you write the correct code in there, okay? And finding them, super easy as well, because your program crashes and you usually get a traceback that says pretty much where the error occurs, okay? I mean, it's not always super straightforward, but for the most part, the syntax error is the easiest error to find and correct. Okay, semantic errors, logic errors, those are more difficult. Why is it more difficult to find a logic error and correct a logic error than it is to find a syntax error and correct a syntax error? Why is that? Does not give traceback. Do you want to back that up with anything else, or does anyone else want to sort of add anything to that? Yeah. As far as the computer's concerned, there is no error. It doesn't give you a traceback because it hasn't found an error. Because the error is not with what the computer's doing. I mean, remember, computers are stupid. They just do exactly what you tell them to do. It will carry out every instruction that you give it dutifully, right? It's not the computer's fault if you tell it to do something and that's not what you actually wanted it to do. Okay, so there is no traceback for finding these logic errors. It's down to you as a programmer to trace through the inputs and outputs and find out where your data is getting changed to something that it shouldn't be. Okay, can someone suggest one feature of the IDE that we looked at last lesson that might help with tracking down where semantic errors are occurring? You are the error. Yeah, that's pretty much what my parents used to tell me. Yeah, debug mode. If you run the debugger, I mean, debug is great not just for spotting where syntax errors are occurring. It's great for spotting how your variables are changing as your program is run, because you have that side-by-side comparison of your code and the variables with their different values, so you can see exactly what's changing when each line of code is run. Okay, and by doing that, you can spot where values are being changed to something that's wrong, and based on that, you can then say, ah, right, there's an error in my algorithm right there, and you can fix that. Okay? They didn't used to say I was the error. They just used to say I was a massive disappointment, which is effectively the same thing. Anyway, moving swiftly on, here's a little challenge for you, and I'll put some background music on for you. Don't worry about understanding what this code is doing, okay? I've written it in such a way that, yeah, you might be able to get what's going on there, but really, you should be able to spot where there are errors, even if you don't understand the code. There's a number of errors in there. There's a number of things as well which are not errors specifically, but maybe shouldn't be in there. Okay, so I'm going to give you a couple of minutes while I play a tune. Don't know what tune. There's this one here, Celtic Fantasy, and it looks like an unpronounceable Norwegian name. So it might be good, it might not be good, but I'm going to play that. And while I'm playing that, see if you can go through and spot where errors occur. Feel free to, you can either hold off before you tell me, or as soon as you spot one, you can whack it into the chat, and then we will go through that. So here's your music. Look at the sass on Alex there. Jesus, do you not know how to use brackets? Like, well, obviously I do, Alex. That's the point. That's why it's how many errors can you count, yeah? So as soon as you spot an error, just blast it down into the chat there. There might be a few which look like errors, but in actual fact are not errors. Okay. I think originally I put 10 in there. I can't remember. Yeah, false needs a capital F. On line 3 here, we need a capital F for false. Now, in most languages, you don't have a capital F for false. Remember, this is Python, so you do need a capital F. We've got bonus brackets. Look here, on if, you don't need these brackets here. You don't need these brackets on the while loop either, or on this if. However, technically not an error. Okay, it's not necessary. I mean, they're unnecessary brackets. It doesn't fit in with correct Python syntax, but that will not cause an error in your program. What else have we got? Where is n? Where is n? What do you mean, where is n? Divide is percent. That's actually well spotted. That you think, okay, that should be divide, but it's not. That is correct. It's the modulus, so that gives us the remainder. So what this line of code basically does is there any remainder for this list of numbers? Okay, so good spot on that. Not technically an error. How much time we got left on this thing? We've got about a minute left of this music. Okay, so the second function is indented. Yeah, look at this. That indentation, that should all be back here, right? I mean, at the moment, it looks like the getPrime function is only defined inside the isPrime function, which is obviously wrong. Now, I don't know whether that would cause specifically a syntax error, but it does mean that in theory you wouldn't be able to access getPrime from outside of isPrime. What about the print command? There's obviously a problem with the print command. isPrime brackets. Where are we looking at isPrime brackets? Print prime. Yeah, so what's going on here? We're missing brackets on the end there. Okay. Print has no ending bracket, yeah. I mean, I think originally this should have been a whole line. So it should have been a single line. Prime number is blah 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 blah. Line 10 is prime 1 2 3 4 5 6 7 8 9 10. If is prime x, yes, so we should have brackets around that x there. Oh, that was the end of the music. No? Oh, I was supposed to play the air horn again. I messed up. Never mind. There we go. Better late than never, right? Okay, so you guys spotted a whole bunch of errors. What about this error here? 2 less than signs. No, we just want a single less than sign. Okay, so there's plenty of it's a fairly straightforward task to discover syntax errors, even if you've got no idea what the program actually does. Yeah, you could sit down with someone else's code without knowing what the code does, and you'd be able to find syntax errors. You wouldn't necessarily be able to find semantic errors, logic errors, but you could find syntax errors. Okay, not error, but you're using x as index. Again, that's not, yeah, that's not what we're looking for. You can use x as an index. I mean, it's a stylistic choice to use I. So anyway, that's cool. You guys have. I think there was some capital letters in the wrong place as well. Somewhere I thought I did a capital P for print, but obviously not. Is prime needs a colon first line? Yes, right here we need a colon. That's one of the #1 errors in Python programming, missing colons. I think we should have some quote marks around here as well. And what happens if you're printing something out and you try to concatenate a numeric value onto it, either an integer or a float, like this? What error are you going to get there? If I say print prime number is plus 12 or something like that, do we get an error there? Does it do that happily, or maybe that's something for you to try out? Okay, so syntax errors, easy to spot. Logic errors, not that easy to spot, but you've got things like the debugger that can help you find them, and if the code is well documented, i.e. if there's lots of comments in your code, you can see what the code is supposed to be doing, so you can compare what that would be with what it's actually doing, so you could potentially fix any logic errors that you have. Okay? Runtime errors, however, are slightly tricky, right? They're easy to detect, in the sense that when you run your program and something happens and it crashes, get into the habit of using comments. You don't have to comment every single line, but if you've got a block of code, there we go, I can talk. If you've got a block of code, you should comment like what that block of code is doing. The easiest way of doing it, if I just go back to my Python, where's my PyCharm there? Just go back to my PyCharm. If I was going to comment this function, for instance, I'd do a triple quoted string, and I'd say divides one number by another. The first parameter is is it the divisor? Or is it the dividend? I think it's the divisor. My maths terminology is rusty. Is that the quotient? Or is it the dividend? I don't quote me on any of this. My maths thing, my maths result is the answer here. I don't know. Okay, but you get what I'm getting at here. That's an easy way of commenting a function. So if someone could check out whether my terminology is correct here, that would be great. When creating a function, can we have vars that don't need to be passed in but could? You can have those variables. So I could do something like this. So I've actually got 3 parameters there. If I don't specify the third parameter, it will set it to a default value. I think that's what you're getting at there. Okay. Anyway, just getting back to what we were looking at here. So when you find a runtime error, it makes you realize that, okay, there's things the users can do which will end up breaking my code. Okay, so they're fairly easy to detect, but what we need to get into the habit of, to avoid runtime errors, we need to be able to anticipate those runtime errors, right? We need to be able to sort of say, right, in any given situation, what is the user going to be able to do that could potentially break our program, right? And if I just go back, sorry to keep hopping around windows and stuff all the time here, but I'm just going to get rid of those comments as well. If I go back to my pointless little program here, right, we can anticipate, we're dividing here. If the user types in 0, we're going to get a divide by 0 error. We can also anticipate if the user types in something here that doesn't look like a number, if it's not numeric, then we're going to get a value error when we try and convert it. Okay, so we can have a look at our code and we can anticipate the sorts of errors that might occur when the program is run, and then we can write code which works around those errors or prevents those errors from occurring. Okay, just off the bat, can someone suggest a way that we could potentially modify our divide function so that it does not crash if we send it if we send it 0 as B in the argument here? Can anyone suggest a way that we might be able to, instead of just crashing, maybe print out an error or return an error that's going to, what steps could I take to avoid this particular runtime error? Anyone? How can I see if the user is trying to type letters or symbols into an input? I'm going to go over that in about 5 or 10 minutes. So just hang fire on that. I'm gonna cover all of that. Any ideas? How can we prevent this divide by 0 error? No one's got any ideas. I mean, the obvious way for me... Yeah, okay, so we have an if statement in there. We don't need to check A because it's always A divided by B, and it doesn't matter if you have 0 divided by something, that doesn't cause an error, right? So you'd have something, I would probably have something like this. If B equals 0, we are going to return something like that. Okay, so if B equals 0, instead of returning a number, we're going to return this error message, which is then going to be printed out. I mean, I could print the error message and return none. It depends how you want to implement this. But obviously, if we haven't returned, we're still at this point, then we know that B is not equal to 0. So we actually get a decent output. And there we can let's put a number in there. There's our number. Our second number is 0. We get error divide by 0. Note that the program has ended simply because that's the end of the program there, but it did not crash. Okay. Why does return exist? Right, return exists. I mean, this, you've got to understand, this is an incredibly simplified version here, right? When you return something from a function, you're sending data back to the place where it was called, right? And that data isn't always just going to be printed out. I've printed it out here because that's what I wanted to do with it, right? But what if I wanted to take that data and further manipulate it, right? So instead of printing something like that, I could do something like this: result equals divide UA comma UB, like that, and then I could carry on doing something else, right? So in this instance, I run the program, and my first number is 434. My second number is 6. You notice it hasn't printed it out. That value of result will still be stored there. Okay, so it means that you can take the output of a function, you can store that that value. You could even pass it into other functions and stuff like that. Okay. In fact, we could do something like this. We could say result equals divide a comma something like that, and then print result. So what we're doing here is we are dividing a by b, and then whatever the result of that is, we're dividing a by that again, and then only then are we going to print it out. So you can see we're gonna, let's have some number, I don't know, 578 or something like that, divided by 2. A is not defined. Oh, it should be UA. There's a syntax error for you. 578, and there's 2. Our answer becomes 2 because what we are doing is we're dividing 578 by 2, and then we are then dividing 578 by the result of that, and we end up with 2. Do you see what I mean? That's a silly example, but hopefully that gives you an idea as to why return is not the same as print. Okay, it's not the same thing. Okay, I mean the reason I can understand why students see them as being equivalent, and that's because in the simple programming that you end up doing at GCSE level, and even at A level to a certain extent, the examples that you use require a fair amount of stuff to be printed out, and what we end up doing is calling the functions, returning the value from the function, and then immediately printing that output. Whereas most of the time, that's not a big deal. Who is Josh and Nessa? I don't know who that is. It sounds completely irrelevant to modern life, though. So, yeah. That's not our Josh, right? His hair's far too good for any girl to dump him. Cool. Right, let's get back to the task at hand. I think that 0 divided by 0 equals 0. No, anything divided by 0 is always infinity. Anything divided by 0 is always infinity. Okay. Right, let's go back to our presentation. Put 100, 0. Yeah, I mean, yeah, sure. If I put 100, 0 into that, I'm probably going to get an error, right? So I didn't say it was foolproof. That was me, like, ad-libbing here. Put 100, and let's put 0, and yeah, we get an error. In unsupported operand type. Yeah. Anyway, so the divide by 0 thing that's the classic runtime error example that everyone seems to use. However, there's plenty of other things that can cause runtime errors. The examples that I put down here, trying to divide by 0, or trying to calculate the square root of a negative number. Okay, if we're talking about real numbers rather than complex numbers. Okay, so if anything divided by 0 is infinity, then instead of making it say an error, it could just say infinity. Potentially yes, but also no. And also, infinity strictly is not a number, and so does not have the data type of integer or float. It's not a number; it's a concept, and so and also you can't then carry on manipulating stuff, and so the computer ends up saying it's an error. Also, returning null or returning none wouldn't solve that problem either. It's always preferable for the computer to just say nope, can't do that. It's impossible. Okay. In the same way that trying to calculate the square root of a negative number, it's not possible. You can't do that. Okay. Sir is about to be beaten to death by Mr. Kirkham. I mean, he can try. Pretty sure I'd win. Where is this hate coming from? Don't understand that. Anyway, right, where are we getting? It's important to understand that divide by 0 and other maths-related errors are not the only runtime errors that can occur. Okay, we can also have things like overflow errors. Okay, I taught you all about overflow errors in when we looked at binary. Can someone suggest to me where overflow errors might occur? See, no one's paying attention here. This is great. You know, it makes me feel really great about myself that I spend like an hour like trying to teach you about computer science, and rather than paying attention to that, you sit and have like chats about people that are completely irrelevant to the topic at hand. If you don't assign enough memory, yeah, not really. When you take away too many times, no, not really. Think about binary. Think about where where does an overflow error occur during binary? Nope. It is not the iteration limit error. It is also not the recursion limit error. Binary, overflow errors. How many times did you write overflow error on your answer to a binary question? What were the adding two 8-bit numbers? What were the situations where you're adding two 8-bit numbers? And this ties in with what you said when you don't assign enough memory. When I said, yeah, not quite, right? It's fairly close, but you need to be more specific there. Adding two 8-bit numbers, what can give specifics? Because I can add two 8-bit numbers together and not get an overflow error. 000000001 plus 000000001 is 000000010. That's not an overflow error, but there are situations where adding two 8-bit numbers together could give an overflow error. Can you give an example? Maybe if they both have 1 as their first digit. Yeah, I mean, there we go. Max. When there is more data needing to be stored than the memory can hold. Thank you, Max. That is the level of detail that I was looking for here. Okay, so if we're adding two 8-bit numbers together and we only have 8 bits to store them, and the result of that addition would be greater than 255, we cannot store that information. We end up with an overflow error, and it's the same like any of those situations. So if we are adding numbers together, I think one of you mentioned repeatedly taking stuff away. That's true, okay? But obviously I was looking for more specific. I think it was Alec that mentioned that. Take away too many times. Yeah, I mean, you keep on subtracting, eventually you'll go below the limit there. Okay, so that can happen in video games. Overflow errors don't always crash the program, but they do often lead to unexpected output. A stack overflow. This is something that occurs when the computer runs out of stack space to store the operations of the computer. Now, you guys don't need to know about the stack. You don't need to know about stack space. And you don't need to know about stack overflows, but you will do if you do A-level. And what it is whenever your computer is executing a program, all of the instructions that it needs to keep track of are pushed onto something called the stack, while the computer is executing those parts of the program, and then they're pulled off the stack. So if you have something which is a recursive algorithm which calls itself from within itself, well, it needs to, when you call a function from within itself, it needs to go through itself and it needs to complete all of the calculations that need to be done before then going back to the place where it was called. So if you're constantly calling a function from within itself, and then inside that function it calls itself again, and it calls itself again and calls itself again, you end up with this massive stack of functions up to the point where you then say, oh, okay, cool, we've solved that part of the problem, now feed it back all the way across the stack, right? And if you do that too many times, you run out of stack space and you get an error. In Python, you may have seen the error recursion, maximum recursion limit reached, or something along those lines. I think by default it's about 1,000, but you can change it. The other thing as well is a library error. So this is where you use an external library for writing your code, and instead of compiling that library into your code, it compiles your code on its own and then assumes that the computer that you're running it on will have that library. Okay, For example, if any of you have played a video game on Windows, you will have needed to use DirectX. And the programs are compiled not to have the DirectX libraries built into them, but because DirectX is shared by all of these different games, it's better to use what's called a dynamic link library, which is a separate file which multiple programs can access. And if that file is missing, then when you try and run the program, it won't have access to the functions that are stored in that library. Hopefully that makes sense. Okay. Now, for the most part, you don't need to know all of this stuff off by heart. Yeah, you need to understand what a runtime error is. I've gone into more detail than I need to at GCSE to give you a sort of broader understanding of what runtime errors are. So as long as you understand that a runtime error is something that is not an error in your code specifically, but is something that occurs when the program is run, either through the user's actions or through things like missing files and stuff like that, then you're good. But I know that some of you are thirsty for extra information, and so I've given you some stuff that you can go on and investigate. So feel free to shout if that doesn't make any sense. I'm aware that we're rapidly running out of time. And so we are going to have a look. We're not going to look at this lesson, but just to give you a heads up, next lesson we'll be looking at how we actually handle those runtime errors. And I did promise that I'd show you how you could check to see if what someone has typed in is actually an integer value. So I'm going to look at this in more depth next lesson, but just to finish up, I will show you this here. Here is an example. I've got my program which asks the user to input their age. Now remember, whenever you use input as in Python, anything that you type in will be input as a string. We want to store age as an integer, so we want to convert it to an integer. But as we've seen before, if you try and convert something that is just pure text, not numbers, you get an error message. And so this is one of the ways that you can detect whether or not something actually will be able to be converted. You can try to do the conversion, and if that conversion fails, right, the way that this works is Python tries to do whatever is in this code block. If you get a specific error, in this case I'm looking for a value error, if you get that value error, instead of actually doing that, which would cause your program to crash, what the program does is it executes all the stuff which is in the except block. Okay. Another way that you could do it, a far simpler way of doing it, which is less elegant in my mind, is you could do something like this. You could do age equals input. How old are you? And then you could say something like if age.is numeric, age equals int age, else print capital P on print. Come on, man. Okay, so there's two different ways of doing it there. They both amount to the same thing. I think this way is slightly better, simply because you can set up your own exception types. So you can add your own traceback errors if you wish. One of my year 13 students created a traceback error that printed out a whole bunch of ASCII art, which was hilarious. So we'll maybe have a look at that. But both of these methods will effectively do the same thing. So what this is doing is it's checking what they've entered is numeric. Basically checks a string to see if it only contains digits. Okay. So there you go. That's one way of doing it. Age equals int age if age dot is numeric, else null. I mean, yeah, we try and keep our code nice and readable. So there you go. Okay, cool. We will have a look at, if you don't understand what's going on here, don't panic, we'll look at it in way more detail next lesson. I don't have any specific work for you to complete between now and next lesson, so does anyone, I see there's only 11 people watching, I'm glad my lessons are that exciting. Does anyone have any questions at all that I can help them with? No questions. Thank you, James. My only question is, why don't more people show up? Or why don't you show up to a lesson? Why do you show up to a lesson and then not pay attention? How, when creating a function, can we have variables that don't need to be passed in? I've already answered that question, Alex. Okay, if you were paying attention, I showed you. So I'm not going to answer that question again. If you want to get an answer to that question, then you'll have to go back and re-watch the video. Okay, so I'm not going to answer that question again. All right, thanks everyone.